Hello, in this video tutorial we want to talk about telemetry, metrics, and the relation of these terms to Prometheus and how Prometheus can be useful here. Suppose that we have our application and our application is running, for instance, like on a physical server or virtual server, and we have a web server application and database. And we want to know what's happening in our application. What are the errors that are happening in our application? What are the number of the requests that our application is serving? Or what is the latency of the responses for our application? So these insights is very important for our business. So that's the definition of the telemetry. Telemetry in software is referring to collecting and storing information about our application, about the performance, error, and the usage of our application, especially in the production. So we are talking about the information, how we can get such information. There are some, you know, resources that we can use to get such insight and information. So in telemetry, we can use logs for getting such information. So as we know, the logs are generated by the application in a text format. It can be a text file that we can open it and check the errors that were created by the application. So we can use it manually. We can check and manage the logs by Elasticsearch and to services like the Datadog. And what the logs provide us is what errors are happening in our application. So as soon as any error is happening in our application, we can get some information about those errors and we can track for fixing such errors. And the point about the logs is that it just gets the information about the errors as soon as they happen, but it doesn't provide us some information about the number of the requests that our application is serving, or the latency of our application, or how many users are using this service. These kind of information are not available throughout the logs, and that's why we need another resource that we can call it metric. Metric is everything that can be measured in numbers. So as we need some insight, we can define them in a numeric format and collect them to get such insight. And the purpose of the metrics is help us to monitor and detect the problems and trends as far as they happen. And the last general resource that we can use to get such insight is traces. For instance, if our API is slow, we can use tracing to find out why the API is slow and we can tackle the problem. But our main focus here is at the moment about the metrics. So what are the metrics? As I mentioned, the metrics are the numerical measurements of our system or application, everything that we can define them in numbers. So, and they can help us to identify the trends and patterns in our system, to check the performance of our system, how it's performing, how is everything is going fine, or there are some problems in our service, and we can identify them before the happenings. And there are a lot of examples for metrics. For instance, we can have the metric for the number of errors per hour. This is useful that we can observe our system that the number of errors are raising or not. If there is, we can check the reason for that. And the other one is the API response time, how our service is, how fast our system is. This is a very important metric. And the other one is for instance, number of our active users, which is really crucial for business. And the other metric can be number of sales per day. All of these can be defined in numbers, so we can call them and consider them as metrics. So metric has three parts. One part is a name for the metric, and the other one is the value of the metric. And each of these metrics are related to a time. So for instance, it's an active user for previous day can be different for today. So as far as we measure a metric in number, we have to assign a timestamp for it. So we can know each of the numbers is related to what time in the database, and we can store them in the database later. One example for the metric is the total HTTP request. So there is a name, there is a value, and there is a timestamp. And this is for just demonstration because it's not timestamp. Timestamp is a long number that will be stored in the database. And as I mentioned, it's just for demonstration. So what the exporters can generate is such format, which is a name and the value, and tools like the Prometheus can store them. But in the next part is we talk about the telemetry and metrics, and what is the relation of these to Prometheus. Prometheus is one of the best tools for tracking and storing, or we can say collecting and storing the metrics. Prometheus has everything for this. Prometheus, first of all, have a time series database, because it's very important that the metrics should be stored in time series, and the time series databases are best tools for such scenarios. And as the Prometheus has time series database and also is great for monitoring and have the capability of alerting, the Prometheus is one of the best tools for defining the metrics and collecting them and storing. And also, as I mentioned, the capability of metric and value, the Prometheus have the ability to filter and query the stored data. And this is another reason that we can use the Prometheus for working with the metrics. And the other reason is we can set up the alerts. For instance, as we mentioned in the previous video, we can check and define an alert, and we can define that if the CPU usage metric was more than 95% in 5 minutes, create an alert, and we can be notified that our system is under heavy load. And also the Prometheus help us to visualize the data. We are talking about the data that is stored in a time series. So the Prometheus, we have to know that has limited functionality for visualization of the data, and that's why we connect Grafana, and they use and the Grafana can use the data from Prometheus to visualize the data in more advanced dashboards. And the next part is the Prometheus database, and it's important to know some of the information about this database. It's a time series database and store the metrics and values in the timestamp. It's an append only and will store the information into the blocks. And blocks are the chunks that the Prometheus database will create and put the data in them. And each 2 hours, the block will be put away, and new blocks is ready for writing data into it. So we have a lot of 2-hour blocks that is representative of the data. And each of the blocks is immutable, means it's read only, and once written it cannot be overwritten. And the data is kept for 15 days. So the data that have more than 15 days, they will be uh, they will be removed from the database, but we can configure the Prometheus to keep the data for a longer period. So let's talk about the Prometheus metrics. Prometheus have some various type of the metrics, because as we mentioned, metrics are nothing just the numbers. So we can just identify patterns and trends by the metrics, but there are some metrics that are presented by Prometheus. There are four type of metrics. The first one is the counter. The second one is a gauge and histogram and summary. Let's start with the first metric, is counter metric. And as the name suggests, is an incremental value, and the number cannot go down. So there are some examples for such metrics. For instance, the number of downloads. The number of downloads is a number that can goes up and cannot goes down. So there are some scenarios that we can reset these metrics to 0, but in overall, the counter metric is something that doesn't fluctuate. And there are some examples for this counter. For instance, the total HTTP request is a great example. Number of completed jobs is incremental, never goes down. Number of errors, number of downloads, and number of email sends. All of these are great examples for counter metrics. And these metrics is very important and useful when we want to track the rates and the speed of increase over the time. And we can visualize it, and it can be something like this graph that we see on this slide. And the Prometheus have some functions for these metrics and help us to calculate the rate of growth in specific time frames for such metrics. And there are some examples for this metric. For instance, when we are using something like an exporter for Prometheus, and Prometheus want to scrape such metric, the metric will look like something like this one that we see. And the first line is starting with help, and we see the name of the metric, which is HTTP request total, and there is a description for this request, for this metric, sorry, and the type of this metric is counter. So we have three metrics here. The first one is indicating the total HTTP request, which is 4,521. Successful get request. We can see that get request and with the code 200, which is indicating a successful request. And the next one is the number of requests that resulted in 404 or not found error message, which the number is 25, and also the number of errors, that internal server errors with the code 500, that the number is 3. So the whole part is the name of the metric and also the number of the metric. As far as the Prometheus will get such metrics, it will extract them and stores them in the database with a timestamp. And as we mentioned, Prometheus have some functions for calculating the rate of growth for counter metric. For instance, the rate function will get the name of the metric, and also there is a syntax that we can define time frame that the rate can be calculated. So overall, this function will result in the average request per second over 5 minutes. But the only characteristic of the counter metric is that it can be just incremental. What if I have a metric that fluctuates? And that's the second metric that is very useful and powerful, and the name is gauge metric. And as the name suggests, it's a metric that can goes up and down. And like a speedometer, the values can goes up and down, has rises and falls, and also the values that can fluctuate. And there are plenty of examples for such metric, like the current memory usage, current CPU usage, current CPU temperature, number of active requests, and the visualization of such metrics like a speedometer, which are available in Grafana dashboard. And the numbers are like in gauge, the numbers can goes up and down between some ranges. And the question is, the counter and the gauge, these metrics seem enough, so we can visualize everything with these types. But the one of the question is that there are some scenarios that these metrics cannot have a response to them. For instance, we have a question. We need to know that the 90% of the response times are less than what numbers. This type of question is related to distribution of the response times. Sometimes we don't need a specific time for a user. We want to have some insights about the distribution of data, or for instance we want to know how many requests fall into certain latency ranges. For instance, if I want to know how many requests are served between 50 milliseconds to 10 to 60 milliseconds, how many requests are fall into this range. So these are the metrics that cannot be responded by the just counter and gauge. And such metrics are a representative of distribution of the observations. And that's where we need more metrics. And there are two more metrics that the Prometheus presented. One is a summary and the other one is the histogram metric. Let's talk about the first metric, which is summary. The summary metric is a metric for calculating quantiles over a time frame. A metric that gives us count and sum of all of the observations. And the great use case for such metric is the latency, response time, or duration. Suppose that we have configured our Prometheus server to collect a metric from our service every 2 minutes. And during these 2 minutes, our service is serving a lot of customers, a lot of requests. And the metric that we are interested in is the latency of the request. So one part is that we collect all 2000 latencies and send them to Prometheus. The Prometheus will store them in the database, and later we can use those information. But it is not efficient, so there is no reason that we have to collect and store all of those information about the request. Instead, we can ask the exporter or the application to get the values of all the latency of the request, calculates them, and calculates the quantile and distribution of those information, and finally expose the results to the Prometheus. So in this case, Prometheus doesn't do much calculation. Prometheus just scrape those pre-computed quantiles from the exporter or from the application, and will store those metrics in the database. And the summary metrics have 3 components. So it's not just one metrics. It has the count, the sum, and the quantile. As I mentioned in the example, for instance, in 2 minutes, there were 2000 requests. So the number of requests are 2000, and the sum can be 2 minutes. So we are observing for 2 minutes, and the count, the total number of the observation are 2000. And the quantile is the distribution of the information that we are interested in. Let's talk about more about the quantile. Quantile is a number from 0 to 1. So 1 means all the distribution of the data, and 0.95 means 95% of our data samples. So for 2000, if we choose the quantile 1, it means all the 2000 samples. And for example, suppose that we are tracking the HTTP request latency, and our observation is just 10 requests, and the numbers are like this and are sorted from the lowest to highest. We can see that the majority of the duration of the request are less than 50 milliseconds. So this is better observation and better insight for our system, that majority of the users have less than 50 milliseconds. But suppose that we get average of this, the number can be misleading. So using quantiles help us that understand what the majority of our users are experiencing, and that's why the quantiles are really important. And the quantile can answer such questions: what do 90% of our users experience, and how bad are the worst 1% of the requests, or this one? And the quantile or the summary metric can answer such questions. And for this case, for instance, if we say that 0.9 quantile, it means 90% of observations, and for this case means that 90% of our users are experiencing a request duration less than 100 milliseconds, and that's why the quantile is important. And there are some examples for such metrics. For instance, if an exporter application will expose the metric for the Prometheus, it can be something like this. As we mentioned, the summary metrics has 3 parts. So we only need this part, which is count, the other part is sum, and the other part has a quantile. And we have more quantile metrics here. So 3 is required, and more can be something added to the metrics. For instance, here the interpretation is that 50% of the users, because the quantile is 0.5, 50% of the users are experiencing the request duration times less than 44 milliseconds. And also we can say that 90%, because the quantile is 0.9, 90% of the requests are served less than 57 milliseconds. And also 99% of requests are served in less than 96 milliseconds. And we have the number of observation and the count. So we can see that we are not flooded with information for 3,250 requests. We just get some insight about those. And these metrics will help us to store these metrics in the Prometheus and track them over time. And the last metric is histogram metric, which is very similar to summary metric. And the only difference is that the summary measures the distribution into quantiles, but the histogram metric will measure distribution of values across buckets. And the buckets are defined upper bounds, like some numbers that we want to know how many observations are under those boundaries. And it's very useful for understanding how many observations fall into each range. Like the summary, it has three components again. The first one is count, same as the summary. Sum for total of the observed values like the, again, summary. And the last one, instead of quantile, it has buckets, which is counts for each defined range. Let's check it an example of the histogram. So like the summary, it should have three parts. The first one is summary, sum, count, and bucket. And we have two more metrics here that are complementary. And the interpretation of such metric is that 140 queries, this is about the database query duration seconds in seconds. So it's saying that 140 queries were executed in less than 0.2 seconds. And the other part is that, again, 470 queries were executed less than 3 seconds. So instead of quantile like the 0.1, 0.5 and maximum 1, we have real seconds here. So if I want to know how many queries were executed less than 200 milliseconds, so I can use the histogram. And also the final part is how many requests were executed less than 10 seconds is 520. And we have the total count of the observations, which is 440. And also we can know that there are, because the total number is 540 and the 520 are less than 10 seconds. As a result, 20 queries were executed more than 10 seconds. So we can know how many really slow queries we had in our system. So instead of, again, storing the information for 540 metrics, we can compute the distribution of data on the exporter or on the client side, which is the application, and finally expose those metrics as a histogram, as summary, to Prometheus instead of exposing all the samples to the Prometheus. So that's it. It's about the telemetry, metrics, and different type of the metrics for Prometheus. In next videos, we will dive into installing the Prometheus and using it for our infrastructure.